All right, welcome to the Unit 1 Cycle 3 Reasonable Domain and Range Notes video. We're going to look at a few examples of domain and range on graphs. So it says, find the domain and range of each continuous graph. So first of all of these graphs are continuous because they are lines. They are not a bunch of dots, they are lines. So that makes them continuous. So we're going to find the domain and range of each continuous graph. One way we represent domain and range is through something that looks like this. It is something is less than, that's what that symbol means, is less than something is less than something. Right? So as a reminder, this is less than, this is greater than. But in this video, we are only going to be using less than. Alright, first of all, first step when finding the domain and range of a continuous graph is you write x in this middle blank and y in this middle blank. Every single time, you're going to have x in this blank, y in this blank. The second step is to find the coordinates of these 2 points, the endpoints. So the coordinates of this point, you would go over 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8. Up 1. Then on this point, you would go over 2, down 4. So that would be positive 2, negative 4. Remember that going up is positive. Going to the right, you're getting bigger as well. Going down is negative, and going to the left is negative. So once I have my 2 points, I'm going to identify which are my x values and which are my y values in those points. So negative 8 is my x values, 2 is my x value, 1 is my other y value, and negative 4 is my other y value. Now, once I have that, I am going to ask myself, which of these x values, if these are my x values, which of these x values are smaller? And I would answer negative 8. Negative 8 goes in the left blank because that is smaller. 2 goes in the right blank because that is bigger. So it would read as negative 8 is less than x is less than 2. Your smaller number goes in the left blank. Your right number goes, your larger number goes in the right blank. Remember, domain is x, range is y. Alright, now let's look at our y values. I'm going to ask myself, which one of these are smaller? And I would answer negative 4. So on my left-hand side, I would write negative 4. And on my right-hand side, I would write 1. Okay? That is how I do example 1. Now let's try another one. Example 2. Sorry, excuse me. One more thing with example 1 is that there are some times where you have a shaded dot, sometimes where you have an open dot. When you have a shaded dot, you have to remember to put a line under less than or a line under greater than, because that symbolizes or equal to. It's saying that the domain or the range is equal to that point. It doesn't stop before it. It is equal to that point. Now, on the other hand, when you have an open circle, you remain the same. It's less than or greater than. You don't have equal to because it gets really close to approaching it, but it doesn't actually get to that point. So it's not actually equal to that point. So on this graph, we have 2 shaded dots. So in this case, all of ours will be or equal to. Okay, let's try to knock out example 2. First step, we write x and we write y, always. Second step, we identify the coordinates of our endpoints. This endpoint, 1, 2, 3, 4, 5, 6, down 2. So left 6, down 2. This one we go over 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. Those are our 2 endpoints. Now, we identify our x values. This is an x value. This is an x value. Identify our y values. This is a y value. This is a y value. Remember, this is our x. These are our y values. Right? We ask ourselves, what is the smaller x value? Our smaller x value in this case is negative 6. Our larger one is 4. Range. Our smaller y value for range is negative 2. So that would make our larger one 6. Now, number 3. It says, how can I describe how to find the domain of a graph? One way you could write this would be that you determine the coordinates of the endpoints and then write down the smallest and largest x values. Okay? Similarly, for range, you determine the coordinates of the endpoints and then write down the smallest and largest y values, because this is your range. Okay? So let's try number 4. It is very similar. Excuse me, on number 3, on number 2, I forgot to mention, we have an open circle here. That is at negative 6. So that means our domain does not actually equal negative 6. So we do not need an or equal to here. Also, our range at negative 2, it does not actually equal negative 2 because that is an open circle. So we leave that like it is. As for this one, our domain does actually equal 4 because it's a shaded dot. So we would put or equal to. Same thing with 6. Our range actually does equal 6, so we would put or equal to. All right, number 4. Let's try to tackle number 4. First step, we write domain is x, range is y in the middle. Next step, we determine our endpoints. So this endpoint would be 1, 2, 3 over, so negative 3, down negative 1. This one would be over 1, 2, 3, 4, 5, up 3. So over 5, up 3. Now we identify our x and y values. This is our x value. This is our x value. This is our y value. This is our y value. Right? For domain, we identify the smaller x value for this point. Negative 3 and 5, negative 3 is smaller, so I write negative 3. My larger value is 5, I write 5 right here. As for range, negative 1 is smaller, so I would write negative 1 and then 3. Now, I have 2 open dots. So if we look back up here, open dots, we leave it as less than or greater than. We do not put the or equal to. So on this graph, we leave both of these exactly the way they are. Because it approaches negative 3 and it approaches negative 1, but it does not equal it. Same thing with 5 and 3. Number 5, we get into infinity, infinite graphs. So if you look, we're introducing something new here. We have arrows at the end. Okay? But let's still do the same steps that we've always done. We start with x and y, and we find our endpoints. So let's find this endpoint because this is still normal. 1, 2, 3. That is over 3 up 2. This is still our x. This is still our y. Now, to discover this one, we have to talk about some things. If you were to go all the way over to the right, forever and ever and ever and ever and ever, you would eventually get to infinity. If you would go all the way up, all the way up, all the way up, all the way up, you would also get to positive infinity. If you would go all the way down forever and ever, you would get to the opposite of this, which is negative infinity. Same thing this way. If you go all the way to the left, you get the opposite of you go to the right, negative infinity. So now if we use those as kind of our coordinates, we can determine the coordinates, quote unquote, of this. Our x would be all the way over here to the right, it would be infinity. Our y would go down all the way down to negative infinity. Again, this is still our x. This is still our y. Okay? Now, same process as earlier, I determine what is my smaller x value. My smaller x value from negative 3 and infinity would be negative 3. My bigger value would be infinity because it's as big as you can get. For y, my smaller would be negative infinity. My larger would be 2 because negative infinity is about as small as you can get. Okay? Now, I have a solid dot right here. So I need to change negative 3 to being or equal to negative 3, and 2 to being or equal to 2. So this is looking really good, but one more thing we have to do is we have to take away our infinities for our final answer. So we have to highlight, if this helps visualize it for you, what we actually need to write. So for the x, let's forget about infinity for a second, and let's just look at what I highlighted. Negative 3 is less than or equal to x. Typically, we write our variable first. So we would write x, and then we would flip that over. It is greater than or equal to negative 3. That would be my final answer for my domain. All I did was I flipped it because it was in a different order. It's still the same thing. Let's try y. This one, they already give it to me in order. So I would do y is less than or equal to 2. This is how I would write my domain and my range for number 5. Okay, let's try another example of continuous. Infinite continuous. Okay, number 6. Same thing. First step, write x and y. This coordinate is easy. 1, 2, 3, 4, 5, down 2. So over 5, down 2. Okay, let's try this one. This is still our x value, right? And this is still our y value. Now, to discover the other point, remember, this is positive infinity, negative infinity. Positive infinity, negative infinity. So this coordinate would be, our x value would be negative infinity. Our y value would be positive infinity. Okay, again, this is my x value. This is my y value. Out of these two x values, negative infinity and 5, my smaller x value is still negative infinity, My larger one is 5. Out of my two y values, infinity and -2, my smaller y value is -2. My larger y value is infinity. Now, we're looking good. Let's check out if we have a shaded dot. Looks like we have an open dot. So all of these will remain as they are. Our last step is we need to take out the infinities. So for our domain, we would write x is less than 5. Just like we see it right there. For our y, we would write -2 is less than y, but like we did over here, right, we're going to flip it so the y is in front. So all we do is we write y is greater than, we flip it, -2. So that is what we would write for our range. This would be our domain. Okay, so let's flip it over. We're going to have more examples. We have now done graphically, so now we're going to look at some real-world domain and range problems, some word problems. Okay, so let's tackle example 1. Example 1, a car can travel 32 miles for each gallon of gasoline. The function d of x equals 32x represents the distance of dx. In miles, the car can travel with x gallons of gasoline. The car's fuel tank holds a total of 17 gallons. First of all, we have to ask, is this discrete or continuous? Well, the way we figure that out is we ask ourselves, can I have 17 gallons of gas in my tank? Yes. Can I have 16 gallons of gas in my tank? Yes. Can I have 16.234567 gallons? Can I have 16.5, 16.6, 16.7, any of those values, right? I can have any of that. So on a graph, that would look like a line. Therefore, it is continuous data. This is continuous data because you can have whatever you want. You're not confined to having specific points. Okay? For domain, remember that this is your independent variable. Range is your dependent variable. So in this problem, we have two variables. We have gallons of gasoline, and we have miles traveled. The way you figure out what is the independent and dependent is you think to yourself, which one depends on the other? So, does the number of gallons in my tank depend on the number of miles I drive? Or do the number of miles I drive depend on the number of gallons in my tank? It's the second one. So our miles would be our dependent variable because miles depend, that's the root word of dependent, the miles depend on how many gallons are in your tank. You can only drive a certain amount of miles if you have a certain number of gallons in your tank. Right? So, for least possible, you determine what is the least possible number of gallons I can have in my tank. Well, you can have 0. You can have 0 gallons in your tank. Maximum possible, we have to look back to the problem. It says the car's fuel tank holds a total of 17 gallons. So the maximum possible gallons you can have in your tank is 17. How that would look like in our domain is 0 is less than x. Remember, x is always in the middle, 17. For range, the least possible number of miles you can drive is also 0, but the maximum possible number of miles you can drive, you have to do a little math. So if we can drive, if we have 17 gallons and we get 32 miles for each gallon, we would have to multiply 32 times 17 to get our value which is 544. So I can drive 544 miles maximum on my 17 gallons of gas. So my range, therefore, would look like this. 0 is less than x is less than 544. Now, we have to go back and ask ourselves, can I have exactly 17 gallons? Yes. Or equal to. So I can equal 17, so I need to put or equal to. Same thing with 0. I can equal 0 gallons. Same thing down here. I put or equal to because I can precisely, exactly equal what I have here. Okay, let's try example 2. Theater students are trying to sell the last 15 tickets for their upcoming play. Each ticket costs $4. Is this discrete or continuous? So, each ticket costs $4. We're first asking, is this discrete or continuous? Well, our values can be $4, and then if we sold 2 tickets, it'd be $8, and then it'd be $12, and then it'd be $16. We can't make like $6. We can't make $5.50. We can't make $5.25. So there are specific values that it has to be. It doesn't look like a line. It looks like a bunch of dots. So this would be discrete. As for domain, we have to ask ourselves, domain is our independent value. Range is our dependent value. Our range depends on our domain. So our 2 variables in this problem are the number of tickets we've sold and how much money we've made. Well, how much money we make has everything to do with how many tickets I sell. So that would make tickets affecting the money I make. Another way of saying that is the money I make depends on the tickets because it's my dependent value. The least possible number of tickets that I can sell, well, I could sell 0. I could do a really bad job and sell 0. The most number I could sell, well, there's 15 left that I have to sell, so I could sell 15. Now, when we write our domain, notice that it looks different than up here because this is a discrete data. So when we're writing discrete domain and range, we use the squiggly brackets. And then remember our rule, we have to put them in numerical order, and we have to put commas, and we have no repeats. So our first value, we could do 0 tickets. We could have 1 ticket, 2 tickets, 3 tickets, all the way up to 15. So as long as you write like 4 of them, you can just put a bunch of dots, 15, because that symbolizes, all those dots symbolize 4 through 14. Don't have to write all those out. Okay? Now for range, how much money can we make? Well, we can make $0. And then for the maximum number of, or a maximum amount of money that we could make, if we sold all 15 tickets and they each cost $4, we would make $60. So that's the most amount of money we could make. Now for the range, what are our values that we could have? We could have 0. We couldn't have 1 because there's no way we could make $1. As soon as we sell 1 ticket, we've already made $4. If we sell 2 tickets, we would make 8. 3 tickets, we would make 12. All the way up to 60. Again, this is what discrete domain and range looks like. This is what continuous domain and range looks like. Looks a little bit different. Okay? Now, example 3. Let's tackle example 3. It says you have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 feet squared. The function A of Q equals 100Q represents the area A of Q in square feet that Q quarts of paint will cover. That was a lot, but let's break it down. Let's first ask, is this discrete or continuous? Well, we have quarts of paint, right? that's covering a wall to paint the trim in your house. So we could have 3 quarts, we could have 2 quarts, we could have 2.5 quarts, we could have 2.4 quarts. We could have any amount of quarts, right? So that would make it continuous. It looks like a line on a graph, okay? For domain, remember, this is the independent variable, this is the dependent variable. So, what is depending on what? Well, the area you cover, area covered, depends on the number of quarts of paint you have. So if you run out of quarts of paint, then this can't get done, right? So this variable, the number or the area covered on your trim, is affected by the quarts you have. So what's the least possible number of quarts you can have? Well, you could have 0 quarts of paint. Looks like maximum possible. Well, we have 3. We could have 3 quarts of paint. For domain, remember you put X in the middle, 0 on the left, 3 on the right. Smaller, bigger. Now these would be or equal to as well, because you could have exactly 3 quarts, you could have exactly 0. Least possible, you could cover none of the trim. You could do that. You could cover 0 of the trim. But the maximum possible, if you used all 3 quarts, you would cover 100 feet for every quart. So 100 times 3 is 300. So you could cover 300 feet squared of trim. For the range, you would put Y, 0, 300. Again, you could cover all of that. You could cover somewhere in between. You could cover 0. So these are or equal to. Okay, finally, one more example. Example 4, it says, Janie has decided to sign up for the yoga classes her gym is having next month. The registration fee is $15 and each class costs $3. Classes will be held twice a week for 4 weeks. Is this discrete or continuous? Okay. Well, she pays $15 and each class costs $3. So she could spend $15, or she could spend $18 if she takes one class. She could spend $21, but she can't spend like $0. She can't spend $16. She can't spend $17. So there's specific values that they have to make. So this would be a discrete data. Okay. For domain, we have 2 values. Remember, domain is independent, range is dependent. The domain. The range, so the range depends on the domain. The domain affects the range. So our 2 variables in this example are classes and the money that she paid. So, if she takes a certain number of classes, that will affect how much money she actually pays. So the money she pays depends on how many classes she takes, right? The least possible number of classes she could take would be 0. And then they will be held twice a week for 4 weeks. So she could take 2 a week for 4 weeks, so that would be 8. She could take 8 if she took them all. The domain, again, looks like what we did up here, right? Has to be from least to greatest with commas. No repeats. So we would write 0. And then she could take 1 class. She could take 2. She could take 3. She could take all the way up to 8 classes. For the money she pays, well, she has to at least pay $15 because that's her registration fee. Right? Maximum possible, you have to do a little bit of math. If she takes all 8 classes and pays $3 for each class, right, that would be 24. But you have to also take into account that she paid the registration fee. So if she pays the registration fee of $15 and then pays for every single class, she would get 39. The way that looks like in range is you do 15, comma 18, right? Because if she pays for 0 classes, she would pay $15. If she paid for 1, she'd pay 18, 21, 24, so on and so forth, all the way to 39. Okay. So those are your reasonable domain and range notes. Please work on the practice now. Thanks.